Well, hello everyone. So here we are. I've got my Norwich tie on. I've got my Norwich City cufflinks on, which must mean not only are we top of the league, but it's a Friday, which is always good, isn't it? So just one more lesson to go. We've got quite a bit to get through. We're going to do some exciting stuff with Surds in a minute. But before that, we've got two things to do, because we've got to go through question 3 of the vector stuff before, and then we can put that to bed for now. So a lot of you did some really good work on that, by the way, so well done with that. And we also have that starter I gave you a few lessons ago and I forgot about, didn't I? So we better go through that. Right, so this is where I got to, and I realised I'd gone fantabulously wrong, so I just thought I'd stop it and let you guys sort it out. Now hopefully where I went wrong was assuming that I was going to be timesing by 2 here, and this would be 7 times 2 to make 14. Actually it wasn't, but the 9 was a good idea, but the 9 needed to be down here, because actually you can also times by 1, can't you? So if you've got 9 and 5, that must be to add up to make 14, and now we're starting to get somewhere. 3 times something take 1, so we must be getting up to 24, so 3 times 8 must go there. If I take 8 away from 4, I get negative 4, and I need 3, so this must be 7 plus 4 making 11 take 8, yep, and we've only got one number left, so the 2 must be up here. 2 9s are 18, divided by 3 is 4. No, that's not right, is it? It's not. What have I done there? Ah, that's because I've got the 9 down here. Dun. And 4 9s are 36. 36 times 2. So that's where the naughty little 2 should have been. And 6 times 7 is 42. So that should be the 6. So well done all of you who did that. And I know some of you sent it in to me and I may not have had a chance to get back to you on it, but sorry about that. So puzzle fans, here's your next challenge. Not going to do that now. We'll do that, may well be beginning of next lesson. Bit of a trickier one. So pause the video, jot it down, have a go at it at some point where you've got a 5 minutes or so where you're not sure what to do with yourselves. Okay. Right, next up we're finishing off got to be just about my favourite grade 8-9 topic. It's a cracker vectors, but I understand if you're new to it, it's not always that much fun. But the important thing here was to look at where P is on A to B, and it's 3/5 of the way along, because you've got 3 parts and then 2 parts, so P would be about there, so 3/5. So straight away I'm going to say that AP is equal to 3/5 of AB, and quite a lot of you got a couple of marks for defining AP, and just defining AB gets you 1 mark. AB is going to be going down there, which is minus A, and then plus your 2B, so is 2, which we can write the other way round as 2B take A. Therefore we can say that AP is going to be 3/5 of 2B take A, and if I expand that, I'm going to get 6/5 B minus 3/5 A. So how to get from A to P is going to come in. It's going to come in because we've got to get from O to P. Now OP is equal to, if I get to A, from O to A, and then I go from A to P, I'm going to be there. And lots of you did this. I was really impressed. So O to A is negative A. A to P, we've just done, is this, plus 6/5 B take 3/5 A. Whoa. I made a mistake there, didn't I? O to A is positive A, isn't it? So that, get rid of that minus. That's positive A. So now I just need to simplify here, and I get that. And quite a few people got this. There were some people who got 3 marks. They got this far and they ended up with minus 2/5. And I got a feeling that's because all the examples we did apart from that ended up on a negative. But if you think about it, 3/5 is less than a whole. If I've got a whole and I take 3/5 away, I'm left with 2/5. So I'm going to have 2/5 of A plus 6/5 of B. Now we want it in this form, so let's just put the brackets around that. Well, 2/5 times A is what we want. So if I put 2/5 there, 2/5, 2 times 3 is 6. So that does work, doesn't it? That is what it is. K equals 2/5 or 0.4. I hope that helps. Wow, now isn't that a thing of beauty? Right, so we are going to be expanding brackets involving surds, and it's going to be surprisingly satisfying at times. Might be, you never know. First of all though, just to get you in the mood for doing a bit of expansion, you've got a few to have a go at there. If you get really confused, then by all means use a multiplication grid for the first two. For the third one, I'd like you to really would like you to try and do that one without a grid. But for the last two, you are going to need, I would say, a multiplication grid. So I would just set one up probably just like that. So for that first one, 3x take 2 and 4x take 3. Okay, I'm going to be quiet now because you're going to pause the video and have a go and then come back to go through the answers. So we should have 2 times A is 2A, 1 times 2 is 2, so it's 2A take 2. The next one here, if you want to use a grid, use a grid. 3 4s are 12, A times A is A squared, 3 2s are 6, A times E is AE. Gives us 12A squared plus 6AE. Don't know why I'm talking like that. When we're expanding just what I'd call a simple quadratic, you know you're going to get x squared. You know you're going to have 3 times 4 is 12 on the end. And the coefficient of x is going to be this one, add this one. So you add the numbers for the coefficient of x and you multiply them, the product, to get the number on the end. Right, not so easy to do when you've got coefficients of x going on. So it's probably best to go over here. 3x times 4x is 12x squared. 4 times 2 is 8, so negative 8x. 3 3s are 9, so negative 9x. 3 2s are 6. Negative times negative is a positive. We can peanut those two. So that's going to give us 12x squared. I'm doing it again. Take 17x plus 6. One last one to do. So here we have, doesn't matter if which one you've done one way, which one you've done another. Remember, it's always about multiplying, never add, very easy to do. 3 3s are 9, so we get 9, x times y is xy. 3 2s are 6, y times y is y squared. 3 2s are 6, but it's going to be negative, x times x is x squared. And 2 times 2 is 4, but it's negative 4xy again. Now the ones we can peanut this time are there. Now why has that happened? It's happened because I was a bit cheeky here and I made the x's the negative one. So this bracket's written the other way round to that one. Right, what's that going to give us? It's going to give us 6y squared. 9 take 4 is 5 plus 5xy take 6x squared. Normally you'd put your x squareds first and your y squareds afterwards, but because it's negative, it's a little bit neater. Okay, so hopefully that's got us warmed up and we're now ready for surds. quick reminder about what a surd is. We know the square root of 16 is plus or negative 4, but what we don't know is what is the square root of 15, because we know that root 9 is plus or minus 3. We know it's going to be somewhere in between, but it's a surd. We can't say more than that. But what we could do is we know it's the number that times itself will give you 15. So I know that root 15 times root 15 is going to be equal to 15. Now that is a disarmingly simple fact that you always need to remember when you're dealing with surds. Here we have a rectangle. What might I want to know about a rectangle? Two things I would suggest often come up in all sorts of questions: perimeter and area. How do you work out the perimeter? How do you work out in fact, let's have the perimeter there and let's do the area down here. So perimeter is going to be that plus that plus that plus that. Simplest way to do it would be to say, if it was a normal rectangle, you would add these two sides together and then double it, or I would. It's what I reckon it's the nicest way to do it. So you could have 5 root 2 plus root 2, and then we're going to double it. Well, if I've got 5 lots of root 2 and another root 2, that actually makes 6 lots of root 2. So we're going to do 2 times 6 root 2. If I double 6 root 2, that's going to give me 12 lots of it. You can think of your surd as if it was algebra. If this had said 5a and this had said a, we would have ended up with 12a as our perimeter. And it's much the same thing that we're going to do here. The only difference is, when it comes to the area, something rather lovely is going to happen. Have a little go if you haven't already. See what you reckon. Well, area we know is length times width. So length 5 root 2 times root 2. Well, what do we know? What were we talking about? Root 15 times root 15. That would be 15, wouldn't it? So that means I can say that this is going to be 5 times root 2 times root 2 is 2. So the perimeter might not be a very nice number. Oh, I should put a unit on there, shouldn't I? Might be 12 root 2 centimetres, but the area is going to be exactly 10 centimetres squared. And that, my friends, is rather lovely. Right, now I know there's no brackets involved here, but this is some important stuff to think about, I reckon, before we get into the brackets. So, what if you had this question? Pause it and have a go before you listen to me spouting on anymore. So, we want it in the form root of a3. In order to do that, we cannot simplify root 6 at the moment. We could simplify root 8, but let's just do 6/8 and see where we get, because one of the rules of surds is that you can multiply together the roots and it'll be the numbers under whatever it is the surd of, and it'll be the root of that same number. Now, if you think about 48, there's a clue that 3 is going to go into it here. 48 divided by 3 is 1, with 1 left over, is 16, isn't it? So what that means is we can say that root 48 is equal to root 16 times root 3. And what do we know about the square root of 16? Well, we know it's plus or minus 4. In this sort of question, you don't need to worry about the negative. You can just go with 4 root 3. Now, here, root 27 plus root 75, we are going to have to simplify both of these separately. So if you think about 27, what are the factors of 27? 1 times 27, 3 times 9. I'm putting a square box around that because 3 times 9 is 27, and 9 is a square number. So the 27 is root 3 times root 9. And the 75, we're getting the idea now, because they've put this 3 on there, that means we know really we just need to divide it by 3. 3 goes into 75 25 times? Yes, 325s, isn't it? Root 3 times root 25. And we know the square root of 9 is 3, so that gives us 3 root 3. And we're adding it to this one, and the square root of 25 is 5. So if we add 3 root 3 and 5 root 3 together, we get 8 root 3. So that is what it's talking about, where it says a is an integer. The first one is 4, the second one is 8. Now I know you've been waiting for some brackets, so I thought I couldn't hold you back any further. So write these ones down and have a bit of a go and see how you get on with it. Now I don't think I should go any further without name checking where I've been getting some of these questions from. A lot of them have been coming from a great free website called CorbettMaths.com. Okay, loads and loads of really good stuff. He does lots of stuff called 5 a day on that, which you may find useful. So Corbett Maths, look out for it. It's got full of good stuff. We will be using his stuff from time to time. Right, so what should we have here? 5 plus root 3 plus root 5 squared. Well, that's the same thing as saying root 3 plus root 5 times root 3 plus root 5, isn't it? So we are going to need, just as we would do if we were doing it with algebra, a little grid. And if I do the square root of 3 times the square root of 3, that's lovely, that gives me 3. If I do the square root of 5 times the square root of 5, that's lovely, that gives me 5. But root 3 times root 5, well, 3 5s are 15. So that's going to give me root 15. Or you can write it as root 3 root 5, but that's not so nice. And that will be root 15 as well. Now we can peanut, well, we've got a double, we can add together the 3 and the 5 to give us 8, but we can also add together in the same way that we would do the x's if we were doing a normal quadratic. We've got 2 square root of 15s, whatever the root of 15 is. It's nearly 4, isn't it? But it's not. So 2 root 15. That would be in its simplest form. And you can double check, by the way, if it happens to be in a calculator exam, you can double check you've put it in its simplest form, because if I do 2 root 15 in the calculator, it says 2 root 15. But if it hadn't been, if it had been, say, 2 root 75, and we did root 75 earlier, and I press equals, I hope you can see there it says 10 root 3. So if you're asked to simplify things in a calculator paper and you're not too sure what you're doing with surds, just whack it in there. Even if you are sure, double check every time. Right, let's do this one over here. So same process. If you hadn't done it now but think you could, then pause it and give it a crack before watching what I do. Now, this may remind you of something that looks like... Remember what that's called? 5 times 5 is 25. 5 times root 2 is 5 root 2. 5 times negative root 2 is negative 5 root 2. Root 2 times root 2 is 2. Because it's a positive times a negative, that gives us negative 2. And what's rather beautiful here is, because it's like this one, it's called the difference between two squares, 5 root 2 plus negative 5 root 2. The the surds disappear, they cancel themselves out, and we're just left with 25 take 2, which is 23. Okay, one more little go and then we'll be done for today. So we've got to rationalize the denominator of 12 over 7 root 3. Now again, I know you can see no brackets here, but it's kind of a bit of that situation. We're going to multiply top and bottom by root 3, because that's going to get rid of the irrational part of the denominator. It's going to make the numerator irrational, but that's not so nasty to look at. So that's the way that we like things to be left. So 12 root 3 over root 3 times root 3 is 3. So that gives us 7 times 3. And 7 times 3 is 21. If I were to get a calculator and do 12 root 3 over 21, in fact, if I was to start at the beginning and do 12 over 7 root 3, that actually gives me 4 root 3 over 7. And what does that mean that I've forgotten to do? I've forgotten to simplify, haven't I? Because 3 goes 4 times into 12, and it goes 7 times into 21. So 4 root 3 over 7. So do remember that calculators simplify surds for you. Alright folks, I hope you enjoyed that nearly as much as I did.